In this lesson, we want to talk about the next part of the gas heating system, which is the gas orifice. The future technician will need to clearly understand the different burner orifices and how to measure gas flow rates for proper troubleshooting. The orifice has one function. It holds the burner gas input rates to a set level, and it meters the gas flow by doing so. Inside the spud of the orifice, there are various angles of approach to the orifice used. The ratio of the orifice diameter to its depth also differs. There are three types of orifice that you need to be aware of: fixed, adjustable, and universal. Fixed orifices are the most common type used of orifice. They consist of a small drilled opening in an orifice spud. These are sometimes formed by laser piercing in materials which are difficult to drill. Adjustable orifices are used mainly in gas ranges and stoves. These orifices consist of two parts. One moves and the other is stationary. The movable orifice hood contains a needle inside the orifice spud, and the spud is stationary. The orifice in a spud or hood moves with respect to the needle. By moving the orifice hood closer or farther away from the tapered needle point, the area of the opening is changed to adjust the gas flow. A fixed spud is another type of adjustable orifice. The orifice spud is stationary. A movable needle is screwed into or out of the orifice opening to adjust the opening size in the type of orifice. Gas rate can be adjusted for 0 with the needle tight against the orifice wall to some full rate. The full rate is set by the size of the orifice with no needle in it. The next type of orifice is the universal orifice. Universal orifices are designed to operate with either natural gas or propane. They are also mainly used in ranges. The universal orifice is a combination of the fixed orifice and an adjustable orifice. The needle is in a fixed position. The orifice hood is free to move. The needle has an orifice drilled through it, sized for LP operation. To operate the range with LP gas, the orifice hood is screwed down until the tapered needle point completely blocks off the orifice in the hood. The LP gas rate is set by the size of the fixed orifice through the needle. To adjust the LP rate, the size of the orifice through the needle is changed. This is done by either drilling out the pin orifice or replacing the needle with a smaller one. For natural gas operation, the orifice hood is screwed away from the needle. The gas will flow through both the fixed orifice in the needle and through the opening between the needle and the edge of the orifice. Gas flow rate through the orifice depends on three things. First, orifice size. Second, gas pressure forcing the gas through the orifice. And third, the specific gravity of the gas. Change any one of these and the gas flow rates change. Remember, the less gas always flows through the orifice than theoretical amounts. To measure the gas flow rates, you can do it by checking the gas flow. To obtain an accurate check of the rate for the gas appliances, you must turn all the other appliances and the pilots off. Leave your truck keys or something important on top of any appliance you're turning off so you remember to turn it back on. For most orifice spud designs, orifice sizes taken from the chart should give you the input rates very close to the desired rate. If an orifice must be replaced with a flat bottom one, the rate obtained may be low for the orifice size selected. If the rate is not close enough to the desired rate, you can alter it slightly by adjusting the gas pressure. In order to measure the gas flow, turn on only the appliance you're interested in and go to the gas meter. Use a watch with seconds to count the number of seconds it takes for the dial to revolve one time. Look at the meter and find out how many cubic feet are used in this one revolution. To calculate the gas flow, which is cubic feet per hour, take the cubic feet per revolution, multiply by 3600, and divide it by the time of revolutions in seconds. The number 3600 converts the seconds to hours. For example, a meter using half a cubic foot of gas per revolution takes 15 seconds to revolve one time with the furnace running. So you have 0.5 times 3600 divided by 15. You should have 120 CFH. A meter that uses 2 feet per revolution of the dial, the time of a revolution is 60 seconds with the furnace running. So you have 2.0 times 3600 divided by 60 is 120 CFH. The heat input rate would be found by measuring the gas flow and then multiplying by the BTU value of the gas. There are tables that have been created to help calculate this gas flow.